right, so we're going to learn some properties of logarithms in this unit. Recall the exponent rule, a to the m times a to the n, and Power Man told us that if we're multiplying, we're going to add our exponents. So I'm going to have a to the m plus n. That's going to be true also with logarithms, since logarithms are exponents. When I have the log of a product, then it's going to be equal to the log of the first plus the log of the second. All right, so we're going to use this, and we really are going to be using it in reverse. We're going to be looking at when I have the log of, and notice that these have the same base in it. They both have a base of b, but when I have a log of m plus the log of n, I want to combine them into one. And whenever it's added, when I combine them, I'm going to combine it with multiplication. So here I have log a of 2 plus log base a of 5. So this is going to be log base a of 2 times 5. And so we'll write log base a of 10. Example 2, here you can see they're all added, so I can do it even with 3 and say that this is going to be 8 times 3 times 2, which is going to be log base a of 24 times 2 is 48. So we can simplify this string of addition into a single log. And then example 3, again, there's no base name, so that means it's what? Base 10, that's right. So that's log of, it's going to be 3a times 2b. So that's going to be the log of 6ab. All right, so the next page we have the exponent rule, a to the m over a to the n. And in order to combine those, we're going to subtract the m exponent minus the n exponent. And that's going to correspond to this rule here with logarithms. So I have here this division, and I can separate it into m, subtract n, same base. So again, we'll be taking it from the long side and putting it into a single log. So here I have a log of 14 subtract the log of 2. So when I combine them, I'm going to make it into a division. These are base a. 14 divided by 2, so the log base a of 7 would be my final answer. And log base 3 of 12 minus log base 3 of 4. So log base 3 of 12 divided by 4. So that's going to be log base 3 of 3. Now we can actually simplify that, right? Because 3 to what power is equal to 3? 3 to the 1 power. So this actually simplifies down to be a 1. So if you've got a number down here, you've got the potential of changing it. 3 to the 1 power is equal to 3. All right, so our last rule here is, I don't know if you can see this, it looks blurry to me. This is a to the m raised to the nth power. So a power to a power, I'm going to multiply my exponents. So that's a to the m times n. So the logarithm rule that goes along with this, what I'm going to do here, you can see my power to a power. I have this power here. So I have an exponent to a power. This exponent's going to move to the front, and I'm going to end up with k times, there's that multiplication, k times log base b of m. So I think maybe that's the harder one to see, but it's a very useful one to use. So here are some examples. Log base a of 2 to the third. I'm going to take that exponent 3, and I'm going to bring it to the front and multiply it. So 3 times log base a of 2 is how I would rewrite that. And for 7, I have log base 3 of 9 to the negative 5. Again, I'm going to bring this to the front. So that's going to be negative 5 times log base 3 of 9. So again, talking about simplifying, here's that base of 3 again. I know that can simplify this part of it here. Log base 3 of 9. 3 to what power is 9? Well, that is a 2. And now I'm going to have a negative 5 times 2 is negative 10. All right, I believe that the next thing we have to do is try these. So try these next 3 examples, A, B, and C, and then pick up again on the next video.